Oh, about what? How do I get to 350 ppm?
What is the
If we reduce from 390 to 350, that will reduce the planet's energy imbalance by ½ a watt. We're presently out of balance by about 3/4 of a watt. So that's not quite enough to do the job, but there's potential for decreasing black soot, tropospheric ozone, and methane, all of which we should do for other reasons because they're very health damaging. And so methane indirectly through its effect on tropospheric ozone. And so we can actually calculate pretty well now the changes in the composition that are needed to restore the planet's energy balance, and that's what's needed to stop additional warming. So that's pretty clear. Now, of course, for a local people, there can be benefits of warming, and people in Siberia think it's not such a bad idea. Unfortunately, if you look at the Earth, we've been in this remarkable period, and I didn't have time for the paleoclimate lecture, but we've been in this Holocene for close to 12,000 years, which is remarkably stable sea level and climate. But that was a fairly unusual period to be that long and that with sea level that stable. If we go back to the Pliocene, when it was just 2 degrees warmer, sea level was 25 meters higher. If you go back to when the period we were talking about, 34 million years ago, when sea level was 75 meters higher, and that's, all the cities. We had completely destroyed half of Antiquity, half of the cities, all the coastline cities. So even though it may feel a little better in some place, that's a little too cold now. It's not something we could live with. We would be leaving a situation, and it wouldn't happen instantly, but once ice sheets begin to disintegrate, then the situation is out of your control. It's going to be continually changing for centuries as the planet goes toward a new equilibrium. So it's hard to imagine any positive things that would outweigh the negative ones.
My name is Matt Mushalik. I'm a peak oil researcher. And you just mentioned that it will take about 10 years for some climate change events to convince even hardline governments to change their policies. My question is, what kind of climate change events are we likely to see in the next 10 years? And I'm asking this because I see a race between peak oil, the accumulated debt crisis, and the CO2 problem in the atmosphere. And my worst case scenario is that by the time such an event happens and really changes politics, that by that time declining oil production has damaged our financial system and our economy to such an extent we may even have diesel shortages, that actually at that critical moment when there would be political will to do something, we can't do it because we don't have the money and not the diesel to do all the projects to get rid of coal.
Okay, I'm afraid, unfortunately, we're pretty resourceful. And there are ways to squeeze oil out of tar sands and out of tar shale, which actually, there's a huge amount of that stuff. And there's no way we can do that without, sending the planet toward the ice-free state. But that, unfortunately, there are still people, and as I mentioned, our Secretary of State signed an agreement with Canada for a pipeline from the tar sands. So I don't think it's going to be an economic collapse, but I think that there will be a realization that we can't do that. And it's hard to say when that's going to really sink in, because some of these things, they're irregular, and climate trends are a signal which is within a system that has a lot of natural variability. And people still dispute whether these greater extremes that we're seeing are due to climate change, because you can't blame a single event on the climate trend. But as the statistics get more and more overwhelming, and I think what's going to happen is, and I'm afraid that this is what's going to happen, that curve that I showed you for the ice sheets beginning to lose mass faster, I'm afraid is going to go down even faster. And then it becomes undeniable that we're sending, and again, it's not because sea level will be going up that fast. Right now it's going up 3.2 centimeters per decade, which is beginning to cause problems in some island nations and things. But what will be clear is that these ice sheets are unstable, and the disasters associated with them will be, unbearable. So we'll have to try to do something about reducing our emissions. There could be other things. It's hard to predict short-term fluctuations in climate. Okay.
Dr. Hansen, thanks for an interesting talk. As I understand it, the world has been warming since the Little Ice Age in the early 1800s, and it's been 3 periods of warming as rapid as from 1970 through to 2000, in the late 1800s, and also 1930 to 1950. Now, carbon dioxide cannot presumably be attributable to all that warming, so why are we giving it all the blame now, and what else is going on?
Let's see if I have any charts on that. Well, for example, yeah, there was warming, as you mentioned, from early 1900 to 1940. It was not quite as steep as the warming in the last few decades. At that the first half of the century, we were getting, CO2 was increasing more slowly than it is now. And there was more of a, really up until 1970s, there was a competition between positive and negative human-made forcings, the greenhouse gases and the tropospheric aerosols. It's true that in the Little Ice Age was cooler, and there was warming after that. But now, only in the last few decades has the rate of growth of greenhouse gases reached such a magnitude that it's really overwhelming natural fluctuations due to volcanoes and the type of solar variations that contributed to the Little Ice Age a few hundred years ago. And we're measuring these other forcings. We're measuring the solar irradiance changes, and they amount to about 1/4 of a watt per meter squared from the max to the min of the solar cycle. And that's not negligible. The greenhouse gas forcing is now close to 3 watts, but it's balanced by aerosol forcing of minus 1.5 watts. So the net forcing is about 1.5 watts, but half of that has been used up in causing this warming. So the net imbalance of the planet is now about 3/4 of a watt, which compares to this solar variation of 1/4 of a watt. So the solar variation is not negligible, but it's smaller than the greenhouse gas remaining forcing. So other factors are important, but humans have taken over as the dominant factor.
Jim, I was explaining to my 6-year-old daughter why I had to be away tonight, and the simplest way I could put it was to say, well, you're my hero. The reason I said that is because as a scientist, you're one of the rare breed that have actually stepped out of your shell and taken responsibility for the implications of the message that you bear for the planet, and responsibility for the world doing something about it instead of staying within your small niche and hoping that the rest of the world would follow. My questions are... And particularly in the light of the recent rebound of magical thinking, or skepticism, if you want to call it that, which it isn't obviously, in the last 6 months, there's a call for more scientists to do the same. And I'm wondering whether you, what is it about you, do you think, that's different? Because there are a lot of climate scientists that haven't spoken out and taken that leap. And do you have a message for your colleagues, and particularly here in Australia, I guess, the scientists that aren't yet maybe as vocal as they could be in educating the public, or putting their policy implications out there?
I think that other scientists have tried to contribute via the organizations, and you can see why they prefer, like IPCC and the professional organizations. And you can see why, because, now even now, just the last few months, I've been getting a lot of flack or friendly letters from people like John Kerry, for example, who even the politicians say, well, you're a good scientist, but why, you may not understand how politics works. But see, I think what I concluded a few years ago is that unless scientists connect the dots all the way to the implications of the science for policy, that those final few dots will be connected by the special interests. And so I think scientists can try to be objective, and it seems to me that it's useful for scientists to try to connect all of the dots. But you can see that, now I'm spending half my time responding to freedom of information requests because their right-wing organizations are determined to put me in the same boat as Phil Jones and the people who've been criticized for loose statements in emails. And they're hoping they can find some email that I've written sometime that will be embarrassing. And I didn't realize, it took me, I guess so simple-minded, I didn't realize that they had people watching our data, waiting to find some error that they could then claim that the whole thing was a hoax. And actually they did find an error in 2007, which was an innocent error, and it affected global temperature by 0.003 degrees, and the United States temperature by somewhat more than that, because there was, anyway, I won't explain the details, but it was the fact that an inconsistency between two of the data sets that were coming into our program. But so we now publish our data completely, and we have published and made available on our website the computer program that analyzes it. So it's pretty hard for them. Well, anyway, I think when other scientists look at the trouble that this causes, it can cause them to have second thoughts about speaking out too much. It's really unfortunate, because the media did such a crummy job of not recognizing the different. In the olden days, in the 1970s, the New York Times had Walter Sullivan as a science writer. If there had been some questions, some contrarians, making some claims, then he would call up the top scientists and ask them, what is the real story? Well, instead now it's presented in the media as any contrarian is equal to any other scientist. And all you would have to do is ask the National Academy of Sciences, what is the story? And is this a hoax, or is this real science? And they would give you a very clear answer. And yet the media is presenting it as if there is a big issue. So it's become difficult. It's almost surreal what's happened in the last 6 months. I couldn't have believed that this gap between what was understood and what was known would actually get bigger, but it got dramatically bigger. And it may be partly because the public is more comfortable thinking that maybe this is a hoax, so we can forget about it.
2 quick points. Michael Stoltz. In 1800, the world population was 1 billion. If the current world population grows by 1.2% in 750 years, there would be 1 person per 1 square kilometer. Of course, we won't get to that, but it's far away in the future. But 750 years back was only in the middle